Maria has an announcement about SI.
Hi everyone. Is this working? Yeah. Hi everyone. My name is Maria. If you don't know, I'm the SI leader for physical science this semester. And Dr. B will show you the times that I have. We already started with SI. I've had sessions throughout Tuesday of last week and yesterday. We've been going over homework assignments and even things that you might be struggling with during lectures. So I highly encourage you all to come and see how SI works and see what you can get out of it. We've also discussed different things like different study skills that you could be using while in class to make sure that you succeed. So things that maybe I have used in the past or things that maybe your classmates are using right now that have been working for them. So make sure that you stop by during any of our sessions. I know Kristen told you, but students who attend SI regularly tend to get at least one full letter grade higher, which is pretty cool. And we also have the SI WordPress site that has some information. I will be posting more as we progress throughout the semester. I have some study skills, like every week I will be posting a new study skill that you could be implementing that will help you succeed in the class. There are also some other resources besides, of course, the ones that Dr. B already gives you, like Khan Academy and other websites that I have used in the past with students and that I used when I took the class to make sure that you fully understand the material and you practice as much as you can to make sure again that you succeed. And I will be posting, if we do exam reviews or anything like that, I will be doing the announcement through there as well. So if you want to find it, you should just Google UCF-SI WordPress and it's going to be the first website that comes up, and then you're going to go on the physics tab and then go to physical science with Maria, and then you'll just find our tab. And again, throughout the semester, I will be updating with anything that I find that I think would help you in any way or things that you could use just to practice. So keep posted, and everything will also be announced during sessions, so make sure that you come and that you are there. Thank you.
Great. Thank you, Maria. And are you going to be in lecture today?
I am going to be here in lecture on Friday too.
Okay, thanks. Students, we're going to do a little bit of a demonstration with a skateboarder to start lecture. So let me pause the recording. Okay, so what we're going to do in part 2 of today's lecture notes, we're going to get the skateboard evolution. So we're going to calculate an average speed based on the measurements that we just did. But first we have a few other things to check into. Let's get to it. A couple things I want to review with you. The homework 1 mix-up, there was a matching item in problem number 3. Originally there were 4 matching items, but one of the questions to match was about something that we didn't cover Thursday, and we're probably not going to get to it today, but probably this Thursday we'll get to the idea of distance polygons. And so I removed that in the new version. Now what we're going to do is reconcile. Everybody's going to get an 8-point score. So the people that did the first one, and a lot of them maxed out because they made some good guesses, but everybody will get a single score out of 8 points, and it'll be similar to the other things I talked about last week. On this case, when I'm reconciling 2 scores, I'll round up to the next whole number of points, give you the benefit of the doubt. So I'll be doing that maybe tonight or tomorrow, you'll see that. Because your guys' homework 1 was still rolling as of about 14 minutes ago. So, but we'll get that done. So sorry about that mix-up. By the way, I'm also sorry about the YouTube. I had to make a whole new version of it, and I didn't have any of your guys' questions. So the reason for that was my headset up here, my USB headset, has a second plug I didn't know about, and it came loose during lecture. So, but it should be good for this lecture. Question up front. Yeah. Yeah, the YouTube video, I made an emergency version for all sections for lecture 2. And it didn't have anybody's questions, and I trimmed out a little bit of stuff. Just the stuff basically that you would need for homework. And let's talk about homework. On the calculation problems in web courses, they tend to put in extra zeros at the end of a numeric answer. Now, usually, always, I will tell you I want the answer to the nearest whole number, the nearest tenth of a meter, the nearest 0.01 seconds, or whatever I want. I'll tell you that. So for instance, if you type in 0.33, web courses adds a bunch of zeros at the end of it. Now that doesn't affect your answer. It's just something web courses does so that it has the same number of decimal point digits, I guess. But if 0.33 is the correct answer, you'll get correct. It'll mark you correct. So those zeros won't turn a correct answer into a wrong answer. So don't worry about that. It's something I wish I could turn off, but I don't know how to turn it off, and nobody knows how to turn it off except the guys at Canvas, and they're not telling anybody. And unfortunately, it's Canvas's way or the highway on this and many other issues. Anyway, so submit it anyways, and if it's right, it'll be marked right. And if it's wrong, you'll know that too. But it's not because of the zeros that are padded on there at the end. All right? Questions about that? Okay. Also, on calculations, it's not in the notes, but I want to remind you, as I reminded you inside the exercise itself, every time you do a new attempt on a calculation problem, it will present you at least one new number value randomly assigned for the problem to calculate with. For instance, on the Icelandic jet problem, I think that was number 2, the distance was changed randomly, and that's what Canvas does. We set up a calculation problem. All right, so just be aware of that. Keep it in mind, because what it means is you can't recycle answers. So if you get it right on your second attempt, like 0.33 meters per second, you can't necessarily use 0.33 on your third attempt or your fourth attempt. And you can't expect anybody else to have that as the correct answer either. It might be, but it might not be. Probably won't be, because it randomly assigns at least one number. All right, so just bear that in mind when you're taking these questions. Question. Wait a minute, your first name? Sadora, okay.
Is it possible that after we do the whole quiz and then we get questions wrong, is it possible for you to put an explanation of why we not the answer, not the right answer, but an explanation of the problem that explains it for us and then we can do it?
Sadora's asking me, is it possible after we submit a homework assignment, is it possible for us to see an explanation of some kind for each question? And the answer to that is yes. And that is something called the rationale, but it's not a part of every question in my question bank. All right, but we could do it. Okay, and in fact, it will do it automatically if that blurb is attached. It's a separate part of the question. It doesn't show when you're looking at the question, but it will show afterwards. And I'll try to add some of that in. The difficult part is the old test banks have rationale, but it's very difficult to change it. And so a lot of the old test bank questions refer to like a textbook we used 5 years ago. And so that's going to be confusing. And so, I find it hard to edit that and change it to something about our current textbook. Okay, so, but I'll try to do that, and because I know, it's helpful for you to see that. So, a little blurb about each question. Okay, another question? Okay, we're doing good here. Now, I had a student text me last night, and I don't have the student's name here, but here's what the student texted me or messaged me in the inbox messaging service. Good evening, Dr. Brickner. I have attempted the homework twice, and I keep getting the same 2 questions wrong. Is there a possibility you could help explain to me what I may be doing wrong? For number 2, I have tried, and then a bunch of other stuff. Now, and I didn't put the student's name. I can't even remember who sent me this message. The point is, what if you have a question like that, using inbox messaging to me is inefficient. There's 400 of you guys in the 2 lecture sections. So instead of sending me a message, it's much, much better for you to post a new discussions thread, or maybe first check the other threads that are in there. Right now, this particular student, I said there's a thread going about this. Sebastian, are you here? Sebastian Vegas. He started a thread yesterday, and Tiffany's from the first. Here's what Tiffany and I typed in. So if you see one of your classmates, how do you get the equation on problem 7 of homework 3 or something like that? And if you know what to tell them, go ahead and type in a few pointers. Don't give them the answer, all right? But give them some tips. And Tiffany Nguyen, she typed in some nice tips for number 2, and then she got in there before me, all right? And I typed in some tips and a photo of a strobe photo of a guy with a baseball. And hopefully the student, Sebastian, I guess he's not here today, or he's shy. He's here. It's not important. But anyways, hopefully that helped Sebastian. And the point is, on a problem, on a question like that, I don't mind, if this were a class of 25 students, it'd be perfectly fine. But even then, I'd want you to use discussions. But with a class of 400, handling even 10% of you with the same question like that, it gets overwhelming for me. And if I don't answer it, and I know there's instructors, they don't answer until a week later, and I try not to do that. So it becomes a problem. But so when you have a question like that, like about homework or lecture notes or something, post it in check discussions first to see if anybody's already on it, and if not, start a thread. Okay, and then we'll click it. And you guys, the rest of yous, if you know a tip to take or what worked for you for registering, the iClicker and stuff like that, go ahead and type something in. All right, and remember to hit the allow threaded replies and also allow liking. And that will help keep the thread really useful and easy to organize. All right? So try to remember that. So if you send me a question and I just type back, check discussions, I'm not trying to be a jerkwad. Okay? I'm not trying to be brusque or anything like that. I am trying to save time, but I do mean for you to check discussions, because what it means is something else, somebody's already got it started. Okay, so you can dip in there and see what you want, see what you need. Textbook website. All right, here's what the page looks like where you can buy it. I'll give you the address here in a second. It's almost ready. You can purchase it now, and you can actually read. Has anybody actually done that yet in here? I had one student. Okay. And how does it work? Seems to be okay? Yeah. It's what? Good. Okay. So nice, easy format. Helpful to go to each chapter and so forth. And this is the first time using this site, so we're going to, hopefully it goes good in Safari, but I don't know. We're going to have to be patient together and figure out methods. Question?
Are the exams only going to be math problems?
No. Exams are not only going to be math problems. Exams are mostly going to be conceptual, multiple choice type questions, matching and true, false and stuff. But we will have some calculations. Yeah. So but it won't be, like all calculations. And I could make a multiple choice test that would make physics grad students cry for mama. So it just depends on what I want to do. And so my emphasis with you guys is not 100% calculation. There will be some, but it should be manageable. Anyway, so there's going to be in this website some mini review assignments, for chapter 1 mini review, chapter 2 mini review, et cetera, et cetera. They're not quite ready. I'm supposed to have a meeting, an online meeting with the textbook guys tomorrow. So hopefully those will be running by the end of the week. We won't need to worry about chapter 1 mini review until next week anyway. So don't worry about that. So for now, we're going to be homework-wise in web courses. But either way, what I want you to remember is the lectures, which are always recorded and video uploaded to YouTube, those lectures are what you want to concentrate on. If I don't really talk about it or touch on it in lecture, even in my own textbook, if it's in my textbook but I don't really focus on it in lecture, then I'm not going to ask about it on exams, all right? But if it's in homework, yes. If I give you an additional reading, which I'm in the middle of making an additional readings page, yeah. If I ask about you in clickers, yeah. Okay. But if I don't, so you have to think about your lecture notes as your study guide. Because if it's not in lecture, it's not going to be on the exam. Although I will tell you that the brain burners on midterms and final, brain burners on homework as well, brain burners and clicker questions are going to be stuff that where you're going to take something from over here and something from over here and try to put them together and make a coherent idea or make a coherent decision based on disparate sources or methods of calculation. So you're going to be challenged by stuff in lecture. So if I ask you something in lecture 3 today and lecture 8 in a couple weeks on on midterm 1, you're going to think, whoa, how do I it's going to feel rough, but it's in lecture, so it's kosher. It's fair game. All right, so be ready for that. So focus on lectures, especially for those of you that miss lecture. That's the only way to get lecture is to go to the YouTube. All right. Now, here's the website address for this page. You can definitely buy it. You'll get an access code of some kind. I don't know. By the way, a student told me at the end of lecture that I hope she was wrong, that the bookstore charged her $170 for the code card back order. I hope she had that wrong. But I do know that they were charging $120 for this. Now, this is the textbook publisher's website. Go ahead and jot it down. It's pretty easy. he.kendallhunt.com/interactions. If you bought something and you haven't redeemed it, and I know the bookstore, I know there's some people that work at the bookstore, but the bookstore is in a business to make money. They're not where I went to grad school, the bookstore was owned by the student government. And so the prices were really low, and they would give you refunds and stuff like that. But I understand the Barnes & Noble bookstore over here, it's not so easy to get refunds. But give it a shot, because this is definitely cheaper. And I wish it was even lower than that. I don't set the price. I write the book, but the textbook publisher, I thought if I made an ebook, it would be, $20 or something like that. And I don't even get it. I make a royalty that goes to the UCF. So the bookstore gets a lot. Anyway, so when you do that, it'll grant you access to the Great River website. Use your NID and your Knights Mail email address when you register. Okay? Do not use your PID. Now, for you newbie freshmen, there's a difference. The NID, network ID, is the first two letters of your first name and then a set of numbers. Okay? If you're a staff member, it might be something based on your last name or your first name. But students, it's two letters from your first name and then a bunch of numbers. And that's your NID. Now, your PID is different from that. That's the ID number on your ID card, your UCF ID. You don't use that. Use your NID. And the reason I'm giving you newbies strict admonition about this is because my first semester on campus, I didn't figure out there was a difference between PID and NID until like Thanksgiving. And I was flailing, it was pitiful. And some guy at the computer center said, yeah, NID and PID, they're different numbers, man. I said, what? Yeah, so anyways, use that for registering. Now, here's another method that you can use. Go ahead and jot down this web address, GRTEP. It's the Great River Learning Products website. And this is the entry page. It's got sign-ins. Let's take a look at this, a little bit bigger. On the left side is the sign-in page. And then on the right side, here's the sign-in or login. And that's going to be your Knights Mail email address and then whatever password that you select. And I usually, when I join up a new website, I change the default password immediately, and I recommend that you do the same. But it doesn't seem to be, at least for me, I have a faculty account, so maybe it'll work differently from you guys. But for me, I had to use the forgot password link. See that down there? And then it'll send a reset code to your email, just like they do, and then you have to answer a question, what was your favorite pet's first name, or whatever, what color was your first car, and then they'll send you a password reset code, and then you type in a new, so whatever your favorite password is. But I suggest you do that. If you want to buy directly from or through Great River, you can do that, and that's over here, first-time user. So if you buy it through the Kendall Hunt Publishers owns Great River. So Great River refers to the Mississippi River. Kendall Hunt headquarters is in Dubuque, Iowa, which is on the shores of the Great River, Mississippi. So they own it, so you can get it either way. And if you have the access code, but if you want to go just directly, click in there. And then you'll select a section, so this is section 2. And then you'll select, then you type in your email address and all that stuff. So it works pretty good, I guess. What did you think when you signed up stuff? Was pretty easy, pretty basic? Yeah. So I think they've been around for a few years, so I think they have got most of the kinks worked out. Okay, prepare your iClicker. Prepare for battle. Battle stations. What we're going to do is type in a numeric answer. So hit the refresh key on your, or actually, if you're not on frequency DD, do this. Press and hold the power button down until the upper left rectangle flashes. Sorry, that should be upper left rectangle. And then type in frequency DD, and then you'll get the Go Nitro message, and then you'll see the ready message. Okay? And if you get the no bass message when you try to click, that means you're not on my frequency. Okay, do this and you'll be good. Now, just a word of warning. If you're using your iClicker for another class and they use like frequency BC or something, that's fine. You just got to switch back and forth. When you get to this class, switch back over to DD. When you get to that other class, switch over to BC or whatever their frequency is. And I used to just stay on AA, but then I was over in classroom building 2, and there was somebody, it must have been right below me or right next door to me in a lecture hall, and they were on AA as well, and their students were clicking through on my system. And because I hadn't started any questions, and the students weren't, I wasn't ready to do it, but I had the clicker ready, and they were clicking through on my, so I said, whoa, where are all these students coming from? I figured it out was the other guy, and we just had competing frequencies, so I switched to DD, and I haven't had any troubles since then. Anyways, so if you're on iClicker, go ahead and get ready. Here's your question, calculating an average speed. So go ahead and start with that. And those of you that typed in 0 and 1, you can now figure out. So give me your answer to something point something something, and then hit the send key. Now remember, on a numeric question, you have to hit send. Otherwise, it won't know that you're finished. So. And we're actually going to do a calculation like this in a few minutes up here on the document camera. So take a minute, and as I mentioned before, it's okay to work with your neighbor and kind of coordinate and kibitz a little bit with your neighbor. Okay, good. Now remember, this is still practice clicking, and we're going to do another kind of a clicker question today with letters to type in just a few minutes. And the official start of clicking is next Monday. So today and Thursday is still practice. You get a bonus point for clicking with a registered clicker. Now I see. One minute. And you guys, I'm sorry, but the decimal point is really hard to see, so do your best. It's very small. I think it's like 2 clicks below the 0. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. I'm going to show you the answer set, and there's a problem here. Okay. Now, a lot of you, and a lot of the first hour class answered 0.82. And I could not figure out, but I overheard some students up here in the front saying, "Oh, you take the first one and divide by the time, and then the second one you divide by the second one and divide by the time, and then you average those two. So 2.5 divided by 3.2, and then 3.93 divided by 4.6, and average those two. That is completely wrong. Okay, the correct. Well, I'm not trying to make fun of anybody, but it's not right. 1.02 is the correct answer. Let me go back over, and not many of you got it, so I want to review the method here, and it's not in the notes, but I will go over the method with you. Here's how it goes. The definition of speed, of average speed, is delta x over delta t. So you subtract your two x coordinates, later minus earlier. So 3.93 minus 2.50. And that goes into the numerator, so that's 1.43. And delta t is the difference in your two clock readings. So 4.6 minus 3.2, so that's 1.4 seconds. And that's in the denominator. So 1.43 meters divided by 1.4 seconds, and that is definitely not 0.82. It's 1.02, and that is the average speed. So make a note of that. And actually, we're going to do a calculation with that right now, because what we're going to do is we're going to do a skateboard speed calculation from our measurements. So let's go to that, and I'm going to switch over to the document cam so that you can, I'm going to do some drawing, and I'm going to incorporate my notes here on the document cam. Rachel's run. So this is 828, 18, section 0002. All right, and I'm going to incorporate this into into the video. Okay, so the basic layout, just make a sketch. Okay, so here's a ramp. So this is the aisle. And Rachel starts here at the top, and down here's Ellie. Okay, we time that distance. Now that distance, what was it, 9.87? Yeah. 9.87 meters. Okay, so that's this distance from Ellie's seat back to, what is your name? Reichert. Okay, back to Reichert's seat, 9.87. Okay, so there's your distance, and we timed it and stuff. Let's write down the times. David, give me your 2 times again. 7.75 seconds. 8.42 seconds. And Ellie, how do you spell Ellie? Your 2 times? 9.32 seconds. 9.32? And your other one? 7.60. Wow, that's a lot of slop. In other words, there's a lot of plus or minus, there's a lot of, uncertainty. And you guys might have different numbers than that. Matter of fact, include your own numbers. Make sure those are in your notes. Now, we're going to take an average of these 4. All right? So let's just add them up. 5 and 2, 7, 9, 11, 14, 20. Carry the 2, 9, 17, 26, 33. Now divide that by 4. So what's 3309? 33.09 divided by 4. So that's about 8.2. 8.27? 8.27 to 2 decimal points? Anybody verify? Yeah. Okay, 8.27. So delta T, 8.27. Okay, so now, so we've got delta T, and then my delta X is, we already measured. We didn't have to make a subtraction there. We already know what it is with the tape measure. Okay, so there's our basic set of measurements and our delta T and our delta X. Now, what we're going to do next is compute the average speed, and this is how you would do it. The thing that I heard the students up front here saying, no, don't do it that way. Take the delta X, take the delta T, and divide them, and that'll get you your average speed. So, now the symbol for the average speed is V with a bar over the top of it. Okay? And I don't use that a lot, but sometimes I do. And here's your, all right. And so now my delta X, just put in, big fraction bar, and 9.87 up here. And down and below, this is seconds up here, 8.27. Okay, now you can see that quotient, that's going to be 1 point something, and it's going to be meters per second. All right. So what have I got there? 1.1. Give me 1 point something something. 1.19? I'm going to verify that. 1.19 meters per second. Let me just verify that. 9.87 divided by 8.27. Change this. Okay, so 1, 827.06. See, this is what you do on the exam if you forget your calculator. This is 1. Put in some zeros. 1600, 1, 827. Yeah, it's going to be 19. Let me just verify here. 3, 7, 15 minus 8 is 7. Right. Carry the 0 down. Okay, now this is going to be 9. Yeah, this is going to be good. So 3, 6, 18 plus 6 is 4. 2, 72 plus 2 is 7. 2 minus 4 is 8. 2. Yeah, okay, so 1.19. Yeah, so that. Okay, so that looks good. Okay, so 1.19 meters per second. So what we've got is the average speed. Now I'm going to go back to, let me put this in my pocket. I'm going to scan this and embed it into the video. You'll see when you look at the YouTube. And you've got it in your notes. And you know, we had different measurements for the early lecture. But that's all right. All right, here we go. So what we just did was did the average speed calculation from our measurements. And hey, you guys, I'm gonna scan the document camera, you know, this paper here. I'm gonna embed it in this place. So this caption is gonna be missing. But my scratch work is gonna be in place of it. And so it'll look nice. You'll see it. All right, now I have some follow-up questions for you on the iClicker. And we're going to switch modes from numeric answers. We're going to go to alphanumeric or short answer. Okay, and you're going to be typing in some letters. So hit the refresh key once, and if you're on the frequency, you'll get the letter A. Raise your hand if you got a letter A. Okay, good. So now we're going to do a practice question, and it's going to be a goofy, you know, it doesn't have Chuck Norris in it, but it has Sharknado in it. So we're just going to practice putting in letters, and we're going to form a sentence. So here's your task. Describe a decision you would make concerning snacking activity. Type in the letters that form your answer. For instance, CBA means sharks consume Cheetos. And then hit the send key. So type in, figure out what you would like to say, look at the list. And bear in mind, I can see whatever you type in, I know it's you. And type in, just figure out. So, and just remember, we're going to do a scientific question using this technique next. So this is just kind of a goofing around practice so you get the hang of it. We'll look at a few of these. They were pretty funny in the first hour. We'll look at some of you guys'. I know some of them were pretty, I don't know. But the nice thing about this kind of a question is you actually get to choose what you want the answer to be. You know, I have to set it up so it's possible to write a correct answer. But this setup, well, this one, I mean, it's a goofy question to start with, but a scientific question like this, there might be, like 80 different ways to write something true, so, which is good. All right, 30 seconds to type in your top secret snacking concept. Good, 171 students clicking. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, let's see what you guys have got here. Oops. All right, now let me switch over to, let's take a look at some of these answers. Okay, here's something that two people, they just stick to the basics. Cheetos. Let's go down the list here, see if there's anything. Let's look at this. AHKD. One person typed that in. Cheetos never move. No. What? AHKD. No. Cheetos never purchase French fries. Oh, okay. Okay, so stick to Cheetos, never purchase French fries. Okay, that's. I was going to say there, Let's see. So let's see what else we got here. Oh, here's somebody that wrote a novel. Good, great. All right. So let's see what this Shakespeare's got here. CBAGPEMON. I'm not going to ask a show of hands, but I can figure it out. CBA. Cheetos consume. No. Sharks consume Cheetos. That's good right there. GPE, always in Sharknadoes. Yes. MON. I prefer my BFF Justin Bieber. Oh, Lord. Who typed? I'll figure it out, but I'm not going to disclose it. Anyway, so Cheeto. Good, nice. Okay. CHKA. Let's take a look at one more. Sharks never purchase Cheetos. That's right. They just take them. Did you ever see a shark in a store? No. Okay. So anyway, so that's a goofy question, but now let's do a scientific one. Let me switch back to the laptop. Okay. Now go ahead and hit refresh again. And let me start. And this is another short one. And this one you're going to actually be describing something about the skateboarder. Describe the motion of the skateboarder on her run. Rachel. And use the following code tip. That's right. Let's give a hand to Rachel and Kate and Ellie and David. Yes. Or you can go like this if you like. So here's the code table. It's a little bit bigger, A through Z. So for instance, MCQ, maniacs are everywhere. But try. So I usually try to have at least one goofy thing in there. So I give you an example that you're not going to use. And I might use this on exam 1. In the clicker part. So give me a serious answer here. And you know what else? Write it down in your notes. Add this as part of your notes because it's good. It's good to think. And this one, as I said before, the advantage of this kind of scientific version, not a goofy one about Sharknadoes, but a real scientific question, you have the freedom of creating an answer that is righteous and true. On a multiple choice, I control everything. I control the question, and I control the 4 or 5 options. That's it. It's total instructor control. But this this. You've got the freedom to create an answer that I may never have thought of concerning the skateboarder's run. You might. So on a test, you'll have a few clicker questions, and I might give you a question like this to create a sentence. And, it might be regular, part of your 50 points for the midterm, or it might be a bonus point question, so you get 52 out of 50. So yeah, I have given these on many midterms and many finals, so that's why we're practicing it today. And we'll see. And the way that I score this, in case you're wondering, and I'll just read this into the video. I take your data, and every student, I can see the letters that you send in the raw data file. And I take the raw data file apart, and I get your letters, and then I break apart your letter, your string of letters, into 4, 5, or 10 symbols, A, B, C, whatever you send. And then I convert that symbol into a word or a phrase from this table. And then I put all those phrases and words together into a sentence. And then I read the sentence and give it a grade. 3 out of 3, 2 out of 3, 4 out of 4, 2 out of 4, or 0, if it's way out there. But definitely put down what you wrote in your notes, and it's good, By the way, you know what? I always get asked by students, Dr. B, how should I study for your exams? And I tell them, when you're looking at lecture notes, always think, how can Dr. B write a multiple choice question about this part of the lecture notes? Or how can Dr. B write a calculation question about, this part of the lecture notes? But this is another one that you can ask. How can Dr. B write a code question about this part of the lecture notes? And that would really be helpful. Think in terms of, because in lecture is important. Everything that I talk about in lecture is important. I try not to, we're not going to always have goofy Sharknado type stuff. And every day I have to decide, well, is this important enough? Can I keep this in lecture? Is it important enough? And of all the million things that I talk about, I'm going to streamline it down to the things that are most important. So if it's in lecture, it's important. And so you can ask yourself, Dr. B thinks, this 5 minutes of lecture was important. How can he turn it into a multiple choice, a calculation, a matching? How can he put, this in as part of a matching question or a code question? All right, 30 seconds to complete. And don't forget to hit the send button if you haven't already. On these, you always have to hit the send because it doesn't know when you're finished. So it's not like multiple choice mode. Multiple choice mode, it just looks for your first click. It knows if you click, that's your answer. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right. Let's take a look at what you got here. Okay, I'm not going to show this one, but I'm going to go down. Go ahead and make a note here. ACN. ACN. Now, only one person put that. Let's see what that is. Speed is... ACN. Speed is accelerating. Is that true or is it false? False. Speed doesn't accelerate. Objects accelerate. A car accelerates. Speed changes when the car is accelerating. But speed itself. So that one I would mark, like partial credit maybe. Let's take another look here. Let me go to something with, a lot of people started with A. So let me go down the list here. See. HAQ, constant speed everywhere. True or false? False. Matter of fact, constant speed nowhere. Because Rachel started at 0. I was holding her back. And then I turned to loose. And Rachel, were you faster at the bottom or at the top? Rachel says she was faster at the bottom. Now we're going to get to the bottom. We're going to get to the bottom of that today and Thursday. Let me look at one more, starting with something other than a. Okay, KCTP. Go ahead and write that one down. Bottom of the aisle is always faster. Was that you, Katie? Or Rachel? KCTP. Somebody typed in KCTP, one person, and it's righteous. Rachel didn't type it, but she could have, because we just talked about it, right? Yeah. So keep that in mind. With this big of a code table, I mean, if there was only 5 words that you could choose, it'd be tough. But with 25, you can have a lot of variations, all of them correct. And you can have some variations that aren't correct. So that's my job to distinguish. But we're going to be using these. Keep your clickers out. We got more clicking to do. We're going to be using these type questions in lecture, on exams, but not on homework. We can't do it on homework. So now, let's take a peek forward. In chapter 2-2, I write in the textbook about Galileo and the idea of acceleration and how the famous Leaning Tower of Pisa experiment. He drops a cannonball and a musket ball at the same time, and they land down on the pavement at the same time. All right? And he used that free fall experiment and free fall in general as his prototype of all acceleration, all accelerating systems. And it turns out that it's a huge strategic victory. If he had done something different than free fall, I don't know, things would have been a lot different. Now, to understand this, to get ready for chapter 2-2, we're going to do some average and instantaneous velocity concepts and calculations here, and specifically about like chapter 1-11, the hare and the tortoise, and chapter 1-10, the Florida Turnpike problem. So let's talk about this, average speed, average velocity. And average is based on a finite number of position and time measurements, okay? And for instance, with our skateboarder, Rachel, we just did that. And the thing about calculating an average, let's see, let's go up the aisle over here. Young man with the black T-shirt. Yeah, and the beard. Yeah. Raise your hand. Raise it high. Okay, what's your first name? Quentin? Yeah. Quentin, when Rachel went zipping by Quentin, I mean, she had a velocity, she had a speed, but we didn't measure the speed when we were there. We only have an average. Okay, so we don't necessarily know what the skateboarder was doing at any one instant of time. The instant she passed by Quentin or anybody else along the aisle between Ellie and what was your name back there? Yo. What was your name back there? Reichert. Between Reichert and Ellie, we don't really know. We know the time that we started at Reichert. We know the time that we finished at Ellie. But that's time. That's not a speed. We computed an average speed. And there was a moment in time when his instantaneous speed at some instant of time was the same number as the average, but, now, so the thing is, if all you know is the average speed of somebody in general, you don't know if they have the same speed all the way, or if if they're taking a break and they slow down, then speed back up, and that's like the tortoise and the hare. The whole thing, the tortoise goes the same speed the whole way and wins the race. And the hare, says, all right, I can really outrun that tortoise, no sweat. So he goes and takes a nap or starts fooling around on Reddit, and the next thing he knows, the tortoise wins the race. So this fable gives us a good idea about average speed and instantaneous speed. Average velocity and instantaneous velocity. Here's a question for you. Which fabled animal, the tortoise or the hare, in the fable, had the higher average speed? The tortoise or the hare? The tortoise, because the tortoise won. You know what I find interesting? If you listen to like NASCAR, they have these qualifying laps where they run to see who's the fastest qualifying lap. They give you the average speed. Indianapolis 500, who's gets the pole position and all that kind of stuff. They go by average speed of your qualifying laps. But that's not your speed all the way around, because you're a little bit slower in the turns and a little bit faster in the straightaways. But whoever has the higher average speed, they get the pole position. And in this fable, whoever has the highest speed wins the race and gets what did the tortoise win? A treasure of gold or something. Whatever he won it because he had a higher average speed. Now, in your textbook, when you get to it, there's going to be a section on the Florida Turnpike, the Turkey Neck Service Plaza. And that's in, I don't know, did you, young lady with the book, what is your first name? Raquel. Raquel, did you notice that they have page numbers in the website? Okay, so hopefully it's still page 11. It was page 11 in the second edition, but it's in chapter 1-10, the Turkey Neck or the Turkey Lake Service Plaza example. Now let's keep going. Let's take a look at that fable. And let's just kind of work at some of the dynamical concepts. Now, Aesop's fables, it wasn't written by Sir Isaac Newton. But, he could have thought about, Sir Isaac could have been thinking about, this, dynamical ideas. And here's a graph of the tortoise's speed over time. So the vertical axis is speed, and this is a diagram from the textbook, a diagram that I created. And it's time in seconds is across the bottom. So at every time, the turtles is radioing back to headquarters, okay, my speed is, 100 meters, or 100, 100 feet per minute. That's the vertical scale, feet per minute. Okay? And so every second he radios back 100 feet per minute, 100 feet per minute, And for him, it's just ditto marks all the way through. Because he gets up to 100. The first second of travel, he's averaging, right down here, he's only averaging 50. All right, but then in the second of travel, he's up there at 100 feet per minute, and he's on cruise control, my friend. And he just cruises all the way through the finish line, and he gets the prize. All right? So you would say that his speed at any instant of time is the same as what his average speed eventually will be computed to be. All right, so his average speed is going to be, pretty close to 100, and at any instant of time, according to this graph, this velocity graph, his instantaneous speed is 100. Now, for the hare, it's completely different. Now, here's another diagram from the textbook, and these are just numbers that when I was writing the book, I thought, all right, let me make the hare, just screwing around, fast, slow, take a nap, fast, slow, take a nap, and so here's the velocity graph for the hare, and he gets toasted because his velocity state changes several times during the race, but his average speed is going to be so low that the hare wins, that the tortoise wins. All right, so these are two graphs of velocity versus time. So make a note of that. Velocity versus time graph. And for us this week, we're going to be talking about velocity versus time. And matter of fact, for the rest of the semester, we're going to have occasion to refer back to this idea of velocity versus time graph, because the shape of this graph is important for us. Now, terminology, in terms of instantaneous speed, the symbol that you would use for instantaneous speed is V of t. So you put V and then brackets, and you pronounce it V of t. In other words, it's a function of time. Now, it's a constant for the tortoise, because he gets up there, other than that first second of motion, he's up there and he just ditto marks all the way across. It's flat. So V of t is constant for the tortoise, and right down his velocity graph is flat. It's up there at the average, and it never steepens, it never dips. It's just nice and smooth, nothing but net. And that's how he wins. V of T for the hare is all over the place. He's got dips and rises and stuff, and he's in addition to that, his average is pathetic. Next time we're going to dismiss. Next time we're going to do something very useful with the shaped graph. Don't leave yet before I give you the assignment. That's right, turn around, soldier. Thanks. Homework assignment is simply this. Get the textbook rolling. I'll see you on Thursday. You're dismissed.